Hello everyone. In this video we're talking about quality control of liquid dosage forms. As you see in the table, these are the points we're discussing in this video. First of all, we're talking about introduction. After that, we're talking about types of liquid dosage forms, then general tests, some specific tests, and finally some additional tests. Quality control is an essential operation of the pharmaceutical industry. Drugs must be marketed as safe and therapeutically active formulations whose performance is consistent and predictable. Liquid dosage forms are pourable pharmaceutical formulations which contain a mixture of active drug components and non-drug components as excipients, dissolved or suspended in a suitable solvent or mixtures of solvents. They are pharmaceutical preparations designed to provide the maximum therapeutic response in a target population where there is a difficulty in swallowing solid dosage forms and or to produce rapid therapeutic effect. Types of liquid dosage forms. Liquid dosage forms is divided into two types, monophasic and biphasic, and the monophasic is divided into two types, which are aqueous and non-aqueous solutions, and the biphasic is also divided into two types, suspensions and emulsions. Types of liquid dosage forms included in this presentation are 1. Solutions. Oral solutions are oral liquid preparations containing one or more active ingredients and excipients dissolved in a suitable vehicle. Water is the most commonly used solvent, although organic solvents are used in combination with water or on their own. 2. Suspensions. Oral suspensions are oral liquids containing one or more active ingredients suspended in a suitable vehicle. Suspended solids may slowly separate on keeping but are easily redispersed. In the manufacture of oral suspensions containing dispersed particles, measures shall be taken to ensure a suitable and controlled particle size with regard to the intended use of the product. 3. Emulsions. Emulsions are dispersion of at least two immiscible or partially miscible liquids. They are oral liquids containing one or more active ingredients which are stabilized in oil in water or water in oil dispersion, either or both phases of which may contain dissolved solids. General tests. Visual inspection is one of the general tests performed in liquid dosage forms. Oral solutions should be clear and free from any precipitation. Any discoloration or cloudiness of solutions may indicate chemical degradation or microbial contamination. Evidence of physical instability in oral suspensions is demonstrated by the formation of flocculants or sediments that do not readily disperse on gentle shaking, and in case of oral emulsions, evidence of physical instability is demonstrated by phase separation that is not readily reversed on gentle shaking. pH test is another general test performed in liquid dosage forms. pH of oral liquid preparations must be optimum as they are administered. The pH value conventionally represents the acidity or alkalinity of an aqueous solution. There are two methods for testing pH. 1. pH paper. The simplest and the cheapest is to dip a piece of pH paper into the sample. The paper is impregnated with chemicals that change its color, and the color may be compared to a chart supplied with the paper to give the pH of the sample. 2. pH meter. If greater accuracy is required, a pH meter should be used. A typical pH meter consists of a special measuring glass electrode connected to an electronic meter that measures and displays the pH reading. Microbiological test is another general test performed on liquid dosage forms. Microbial contamination is determined by the total viable aerobic count, which is the sum of the bacterial count and the fungal count. The test allows quantitative enumeration of the mesophilic bacteria and fungi that may grow under aerobic conditions. Plate count is one of the methods used for determination of the total viable aerobic count. According to the United States Pharmacopoeia and National Formulary, the product complies with the test if no colonies are present or if the identification tests are negative. As for suspensions, sedimentation volume can be expressed as the ratio of the ultimate volume of the sediment to the original volume of the suspension, which may be calculated by the following equation. F, which is sedimentation volume, equals Vu divided by V node. The values of sedimentation volume, which is F, can give indication of the physical stability. As we can see in the table, if the F values equals 1, that means no sedimentation and no clear supernatant. And if the F values equals 0.5, that means 50% of the total volume is occupied by sediment. And if the F values is greater than 1, sediment volume is greater than the original volume due to formation of floccules which are fluffy and loose. Redispersibility test is another test used for suspension. Redispersibility describes the ease of redispersion of the formed sediment by moderate shaking to yield a homogeneous system. Ease of redispersion of the suspension can be determined either by 1. Simple agitation of the suspension in the container, or the use of mechanical shaking device which stimulate human arm motion during the shaking process and can give more reproducible results. Particle size change is another test used for suspensions. Any change in the particle size of the suspension can give an indication of crystal growth. The freeze-thaw cycling technique is applicable to stress the suspension to promote crystal growth, and the particle size can be measured by using either a microscope or the Coulter counter device. Suspensions must be firstly diluted and deflocculated to ensure that each individual particle is measured rather than each floccule. This method indicates the probable future state of the suspension after long storage at room temperature.
Test for emulsion. Phase separation. An approximate estimation of phase separation might be obtained visually. In general, creaming, flocculation, and coalescence have occurred before phase separation is visible, thus sometimes making quantitative evaluation more difficult. The rate and degree of phase separation in an emulsion can be easily determined by keeping a certain amount in a graduated cylinder and measuring the volume of separated phase after definite time intervals. The phase of separation might result from creaming or coalescence globulus. The phase separation test can be accelerated by centrifugation at low or mild rate speed, as we can see on the right side, using a phase separation method to determine if it's a good emulsion, coalescence, flocculation, creaming, breaking. Another great test for emulsion is droplet size. The growth in the droplet size after the preparation of an emulsion is an indication of its physical instability. The droplet size is measured by microscopic method or by electronic devices such as Coulter counter. In emulsion containing droplets greater than 1 micro, optical microscopy is particularly useful because it provides a direct and comforting measurement of individual droplet size. The Coulter counter method used a Barrett's tube, electrolyte, cathode and anode, and then the droplet passes through a monitor that measures the particle size of the emulsion. Another test for emulsion is dilution test. Dilution test is used to identify the emulsion type. Take a few drops of the emulsion in the test tube and dilute it with the drops of water. If the water is distributed uniformly in the emulsion, then the emulsion is oil and water type. But if the water separates out as a layer, then the emulsion is water and oil types. As we can see here, we have a emulsion in the test tube. We put a few drops of water. If the water is distributed uniformly, then it's oil and water emulsion. But if the water separated out layer, then it's water and oil emulsion. Additional test. Zeta potential test. This test is applicable for suspension and emulsion. Zeta potential has a practical application in stability of system containing dispersed particle, since this potential governs the degree of repulsion between the adjacent similarity charged dispersed particle. Value of zeta potential reflect the future stability of suspension and emulsion, so it is monitored time to time to ensure optimum zeta potential. Determination. It can be determined by observing the movement of droplet under the influence of an electrical current, electrophoretic mobility measurement, often in a conjugation with a photon correlation spectroscopy. As we can see in this table, we have a list of zeta potential and stability behavior. Let's take, for example, plus or minus 40 to plus or minus 60. We have a stability behavior, a good stability. Or, for example, more than plus or minus 61 is an excellent stability. Uniformity of content. For this test, as per British Pharmacopoeia, say 10 units individually using an appropriate analytical method. Carry out the assay on the amount of well-mixed material that is removed from an individual container in a condition of normal use. Express the result as delivered dose. Calculate the acceptance value using the following formula: M, mean the reference value, minus X, mean of an individual content, expressed as a percentage of the label claimed, plus K, acceptability constant, multiplied by S, which is mean the sample standard deviation. According to British Pharmacopoeia, the preparation complies with the test if not more than one individual content is outside the limit of 85% to 150% of the average content, and none is outside the limit of 75% to 125% of the average content. The preparation fails to comply with the test if more than 3 individual content are outside the limit of 85% to 150% of the average content, or if one or more individual content are outside the limit of 75% to 125% of the average content. If 2 or 3 individual content are outside the limit of 85% to 150% but within the limit of 75% to 125%, determine the individual content of another 20 dosage unit taken at random. The preparation complies with the test if not more than 3 individual content of the 30 dosage unit are outside the limit of 85% to 150% of the average content, and none is outside the limit of 75% to 125% of the average content. In accordance with the British Pharmacopoeia and USB, limit for the content, uniformity, and mass variation test of oral pharmaceutical liquid are given in Table 1. As we can see in Table 1, we have dose and ratio of active substance. So, if it's more than 25 mg dose and more than 25% of active substance, we use mass variation for solution and content uniformity for suspension and emulsion. If it's less than 25 mg of dose or less than 25% of active substance, we use mass variation for solution and content uniformity for suspension and emulsion. This is the reference we used in this video. You can find it in the description. At the end, thank you guys for listening. I hope you understand and enjoy our lecture. Thank you very much.